Horn gates lowered, lowering barrier gates. Barrier gates lowered, pulling span locks. Junior, are you all clear? Raising all 4 leaves.
This is the motor. It's 70 horsepower. For every 540 revolutions that this motor makes, this shaft right here turns once, okay? So it actually will open the bridge in about 2 minutes.
This project is a replacement of the existing Brightman Street Bridge. We've doubled the size of the opening. The existing bridge is a 98-foot opening at water. This new Veterans Memorial Bridge is 200 feet.
Through an engineering standpoint, we want to take a structurally deficient bridge out of service. And that's the bridge that's just downstream, about 1,000 feet downstream here. When we started this project, it was able to support 18 tons. It went slowly down to 9 tons, and it's been reduced to 3 tons now. So now, all commercial vehicles cannot use that bridge. This has no weight limits on it, so all commerce can use this bridge. So that's the greatest thing that can happen to the community. Traffic will flow a lot better through this whole area.
Because of the project being so large, the concept was to try to divide it into separate contracts, feasibility-wise and monetarily-wise, to get it done efficiently.
We started back in 1997, building just the approaches on the Somerset side and on the Fall River side. That contract was about $2 million and lasted about a year and a half.
What was the most difficult part of the job?
The substructure. There's 18 drilled shafts. They're 8 foot in diameter, and they're drilled down through the river bottom, and then they're rock socketed 25 feet into bedrock.
Wow.
And then they're filled with concrete and steel. That was our biggest challenge. All the approach spans and all the substructure work for the ramp systems are under the second contract, and that was a $45 million contract. The third contract was actually building the bascules which support the movable part of the bridge from bedrock all the way up to what we call elevation 18, which is 18 feet above sea level. What we're looking at right here, this is called the trunnion, or it's a pivot point of a movable bridge right here. Counterweight's 2 million pounds. This portion of the bridge is 2 million pounds, plus about 1,000. Because what we want it just slightly tip heavy so it will close. The final contract, which was the most expensive contract, includes all the superstructure of the bridge and all the mechanical, electrical, and structural components of the movable bridge.
You can see the teeth, the gear.
We're
going down there?
Wow.
Yeah, that is the biggest gear I think I've ever seen. All right, that's good. I want to touch and play with that. There we go.
So what we're looking at here is actually 18th century technology really combined with all the electronics that we have today. I mean, a rack and pinion, which Dave just said, is something that's been around for centuries. One of the most amazing parts of the bridge is the braking system. This drum right here with the brake shoes on it, it's not much bigger than you'd see on a 6-wheel dump truck. And this is actually what brakes the bridge. It's so well balanced that it doesn't take much just to stop the bridge and brake it in the up position and brake it as it's coming down.
All 4 leaves, fully seated. Span locks driven, raising barrier gates.
This project encompasses a bike path. It is 10 feet wide. It's separated from the traffic by a barrier and 2 high rail.
We've been ramping up quite a bit, getting a lot more work done, repairing a lot of the structurally deficient bridges and roadways in our area. So there's been a lot of work that's gotten done, and there's still quite a bit ahead of us, but we've taken a lot of bridges off the list.